today we're working on a monolithic flash drive. This flash drive is made by Kingston, I believe. It's currently sitting on this paper towel, which is blocking everything for you. The reason I put it on paper towel is just because I'm going to use this fiberglass scratch pan to remove the black coat on the back of this unit, so I can expose the circuitry that's underneath it. Circuitry exposal is a must for working with monolithic devices, because through the interface we don't have any communication. The device does not get recognized. I'm not even going to try plugging it in. If you found this video because your device is not working, that's probably the reason why. If you can't see the device come up in a device manager, if data recovery software does not detect the unit, chances are it's going to need NAND extraction. Flash drives can be of two types. They can be monolithic, like this one, where everything is embedded inside of one chip, or they can be surface mount, like this one, where the memory is a removable component which can be desoldered, placed into a specialized socket that is already pre-routed to read and read that way. Because this is a monolithic unit, some adapters do exist that can make that easy connection as well. I do not have one for this device, so we're gonna have to put some elbow grease into the project and use a monolithic breakout adapter similar to this one, and similar to how you see this card being wired up with a bunch of wires. We're gonna need to do that same thing for our patient right here. Using this fiberglass scratch pen helps us to remove the black coating up there in the least aggressive way for the device, without using something like a laser. Laser would be obviously the best, but I don't want to buy a laser just so that I can remove coats of flash drives, which takes only a few seconds to do. Maybe if I was doing some other work that required a use of a laser, that's a completely different story, but just to flex on forums and Instagram that I can remove the coats from these devices clean, I don't want to spend the money that lasers cost. This is $5 and lasers are like over $1,000, so there's a big difference. Alright, so our device is prepped. What's next? Once it's prepped, we can turn this off. We need to locate a schematic for the wiring. So going into monolithic pinouts database here, it's going to give us a lot to choose from. So we have some switches here to break down our search. We're going to use USB flash drive, we're going to use technological pads, and we're going to use normal size. There's the device I think we'll have to use. And in order to verify it, that it's a schematic that's going to be correct for us, we need to look at the VCC, which is 1, 2, 3, 4, but the ground is 1, 2, 3. This is the ground here, and that's how I'm going to test if the match is correct. As you can see, the ground is in the same place. Sometimes it has a alternative pinout, but in our case I think we're good. We're gonna need an adapter and some tape. We're gonna need flux, so right now what I'm doing is I'm pre-tinning all of the joints that we're gonna need to link up to. These are the signals for command and the bus. So the entire top row is used. And now we just wire it up. So let me grab this wire, tweezers. Alright, so we're done with the wiring of the bus signals. Now we just need to worry about the command signals. Okay, our channels are wired. WE and RE are underneath it. WE and RE. This is the ready and busy. Address. Address latch. Oops. And command latch. That's done. I'm going to use a thicker wire for the other two signals. These are not signals, sorry, but for the power and the ground. This is the power. And the ground we can pretty much mount anywhere we want. Just kind of a couple of small things I wanted to modify. The VCC, I'm gonna give it a little bit of slack here so I can bring up the contact like this. Okay, for the most part the soldering is finished. Just gotta check for the shorts. So red probe on the ground. I'm gonna check all of the signals that I wired up. They should produce this single short beep. All right. No short to ground. Excellent. So we are able to test it out. And we got an ID. Perfect. So we got 76, 76. What is the difference? Oh, one is the DDR and another one is SDR. So if we got the DDR, we can figure that out as we go along. You see, it's only halfway, right? And the reason it's halfway is because we have a wrong config. Halfway, it doesn't show us the full thing. So going into workspace, again, turn it off, and we're going to select DDR, go into dump viewer, bitmap, and we'll see our bitmap extend all the way beyond half. However, this is interesting right here. If we highlight the blocks, we have like a split here and here. And if we're going to scroll across, we're probably going to find some dark straight lines. Indicating to us that we have bad bytes that will need to be removed. Everything needs to be lining up. We can't have blocks not line up. But there it is. You see this vertical line right here. So this line, it's a defect that factory had covered up, and through controller, this defect is not affecting the performance. It's hidden. But when we read the NAND without controller, it comes up. So this tool will simulate the removal of these bad bit columns, and we will be able to get it all lined up and clean. But first thing we need to do is read the chip. We'll read it with stock settings and do error correction and scramble removal afterwards. So going deeper into the project, I realized that this was more than I could process on my own. This case could not be built using block sequence, and market stable, I don't know how effective it would be throughout VNR. I have to reach out to the support and find out from them if there are solutions for this type of controller. So I opted for something that has a virtual translator option, which is a flash extractor. Sadly, Flash Extractor had recently stopped its developments, and it's a really sad moment in data recovery flash industry overall, at least for the users, because this was a really great tool. I've done many recoveries using this tool, and for me it saddens to see things that you worked with for many years eventually come to an end. Thank you, Sergey, for making this tool. It was, I'll definitely keep on using what's left of it, and who knows, maybe in the future we'll see something new from you. Anyways, so getting back to the video regarding this case, here we are. The translator is built. The procedure for building a virtual translator on this type of controller consists of a few steps. They time-consuming steps, so I didn't include them in the part. But first, we run automatic slow search for first 10 blocks, so we change this value to 10, and we scan it. That scanning process took approximately an hour for this type of card. So it finds the blocks to start the file system, and then the rest you can run it as auto fast, and it starts to compile the rest of it. And overall, what I ended up with, the result wise, it's pretty good. So I already did save the image for it, but if we go into Explorer, we can see that the structure is present. We see that FAT32 looks good. The root for us is valid. It has the folder structure. Folder structure appears to be in great shape. Some of these red dots that appear here, you guys don't see the file names, but it's a duplicate for the file. So there are only 2 files inside of this folder. And if we were to check out, let's say, some sample files. There is a PDF that I just opened up. It works. And if we want to see a preview of the image, there it is. Also functional photograph. So at this point, the data needs to be saved, compressed, and delivered back to the client. As you can see, primarily the map is all green. So that's it. The data is saved, and yeah, I'll need to reach out to VNR and PC3000 people to find out what is there to do when this type of flash drive occurs, because I did see some options for building this on PC3000. There must be, again, options for building this on VNR as well, but because I can't see any markers, I don't know how that block sequence arrangement should be set up. So anyways, a little bit of a challenge. Took me a little bit of time, but I mean, I should have started with FE as soon as I saw that this is the controller type. FE for assemblers is the tool that has virtual translator available right from the start. So I should have done some research on that ahead of time and saved myself a few hours. If you lost data on flash drive and you need it back, don't hesitate to reach out to us. Links, as usual, are in the description to get in touch with us. And if you have some questions, drop them in the comments below. I'll answer you all. Thank you very much. I'll see you next time.